Hi guys, this is a long-awaited Unit 4 review, and I actually don't know how long this will take. College Board has, I think, 3 almost 50-minute long videos on just this unit because they know that you guys struggle with this unit a lot. And I am pretty sure your probability will be on your test in one way or another. So like the big topics in the probability unit are these. So a simulation, if you remember the gateway, it's basically you set up the problem in a way so that you can simulate instead of actually going through what you said in the problem. So like you can use, I don't know, number, like random number generator, and then generate random numbers to kind of simulate what you do. I don't know if simulation will be on it because there are many other things that you can test, although I don't know how they're gonna, come up with the problems. So simulation, I think if you can try a couple problems, you will understand what this is all about. So I'm not gonna go over simulation per se here. Probability rules, I think as long as you have a formula sheet, you'll be able to do them. So I'm not going to focus a lot, but I'm gonna show you the slide that I have all the rules written. Mutually exclusive and independent is a little bit more important concept you need to remember. And so we're going to talk a little bit about that, and there are some formulas that will go into it. Conditional probability is huge, and with this, you will also see two-way table. And so reading the two-way table is very important. You need to know how to read it. Random variables, you might be wondering what is this? This is the x. When we start talking about discrete random variables versus continuous random variable, so that's where the random variable comes from. And everything after this chapter was basically random variables, right? Expected value, variance, standard deviation, you looked more into these things whenever we looked at random variables. So like below this is basically after the introduction of random variable. Binomial distribution and geometric distribution, very important, and you will most likely see this problem in a test. Geometric, we didn't really emphasize this in class because binomial was a lot more important, but we will review geometric as well, just in case it shows up. And you need to understand the main difference between the two. Alright, so let's go to the next slide. So this one, I just tried to put all the probability rules. So let me go through a couple of them quickly. So sample space, right? Very important word. It's basically all the possible outcomes. So you need to know what outcome is. And some of the probabilities are always 1, right? So 100%. You cannot have over 100% or less than 100%. But because of some rounding issues, sometimes when you create your own probability, it might not add up to 100 or 1. That's why showing your work is very important, because then they can say that, oh, this was a rounding issue, but they understand the probability rules, okay? It always has to be between 0 and 1. You don't have a negative probability, right? So it's basically explaining what 1 means. When you have a probability 1, it's just like always happening, and probability 0 is like never happening. Okay, the probability of outcome occurring equals 1 minus the probability that it doesn't occur. Okay, it just means that because everything adds up to 1, if you have a 1 event that's like 0.5, then the other event has to be 0.5 if you have only 2 outcomes happening in the sample space. All right, mutually exclusive, first time it appeared. Another way to say it is disjoint. So whenever you see a disjoint, don't get surprised. It's mutually exclusive. And basically, so mutually exclusive is 2 events that will never happen at the same time, right? So that's why it's that 2 mutually exclusive events occurs as 0. So there is no such thing as A intersect B. So this is always 0 for mutually exclusive. All right, so these 5, 1, 2, 3, 4, 5 is from your what's it called? Formula sheet. So you will see them. And then this one, it says it's not on formula sheet, right? So here again, if disjoint or if mutually exclusive, then your intersection is 0. And if some two events are independent, then this is a conditional probability we're going to look at a little bit later, has to equal P of A, right? So this one, the first one is red, P of probability of A given B, right? So the second one was the given B. If that is equal to just probability of A happening, then it was independent. Another way to look at it is this way, right? So there are two type of formulas that you can use to check if if two events are independent. These are more for the what do you call it? What was the word? Combining random variables, and so these are important in combining random variables. So remember that you couldn't combine the standard deviation together, but you could combine the variance together. So that's why you always see square of something, never just adding the two standard deviation together. Z-score, it's the same for every, Z-score is always the same. So you need to just remember how to find a Z-score. It's always whatever you're interested in minus mean over standard deviation. So I think one of the more used one is this one for sure. The conditional probability will be always on the question because two-way table is one of the easiest way. This one we'll see again. It's a binomial distribution, so we will also look at that more closely. All right. Again, this is just basically written on whatever we read on the probability. Complement is basically, so it's like this. If I have a Venn diagram, Venn diagram A, and there's everything else, right? This part, this outside where A isn't, is A of complement of A. So sometimes you write as C, sometimes you write as like a little, like a prime and things like that. This joint event, no common outcome, we've talked about that. Independent probabilities means like it doesn't affect each other. So like rolling a die, even if you get a 1, it doesn't affect your next outcome, right? So just because it had 1, you're not guaranteed to have 1 again, or you're not guaranteed to have 1 again. It's like, it doesn't matter. It will always be independent. Independent means always the same probability. And these are, so this one is only works if your events are independent, right? So you see it from here. It has to be if A and B are independent. Okay? But this one is a general equation, so this one always works. It doesn't have to be independent event. P given A is very important, conditional probability, and we talked about it here. P given A, and if that equals to the first one, P of B, then it means independent. Let's go to the next one. Discrete random variable and continuous random variable, I mentioned it very briefly. Discrete random variable is basically like you count, right? It's a counting. So if you're counting a number of people, counting number of things, so it's like 0, 1, 2, 3. There's no number in between. This one is continuous, so like you will see it more like this because you could have any value between 1 and 2, or 2 and 3, and so forth. Okay, so this one we often draw a table like this, 0, 1, 2, right? Because it is possible to have a category for each number, whereas the continuous random variable you really don't. Okay. Expected value is a long-term outcome, right? So it's not something that you will be able to apply for the next time you play the game. It's like when you play this game a long time, what would be my expected value? What would be the average in the long run? Okay, and that was basically x times p of x, and then you add them up. Variance. So it was like the mean, so like basically what you found from the expected value, and then you subtract mean from each of your x values, and then you square it, and then you multiply by the probability. So that will give you the variance, and then the relationship between variance and standard deviation is always the square. So if you take the square root of variance, then you get the standard deviation. So these are always easier to find it using the table, but they're probably not going to have you find them by hand. Even if they do, you have a formula sheet next to you. So these are going to be very useful things to write for your notes, right? For your open note, open book test, because you don't want to like flip through your textbook to find just this formula. All right, means of two different variables. So this is the combining random variables, right? If you have two random variable x and y, okay? If you're adding them, what happens to the mean is that you add them together, right? And same thing as subtraction and multiplication and division. But for the standard deviation, I told you that you cannot just add or subtract standard deviation. You have to get the variance first for anything, okay? And then square root to find the new standard deviation, okay? So remember, standard deviation, you cannot just add two random variables. At binomial geometric normal. Binomial distribution and geometric distribution, like we talked about something called, I don't know if I actually gave you the term, like Bernoulli trials. So it had a very specific conditions that you have to meet to call something a binomial event or geometric event, right? So you have to have two outcomes, success and failure, right? So if you have like if you're rolling a die, what would be the success and failure? Well, it depends. If you're calling getting a 1 as a success, so that means the rest of the events, like 2 to 6, you getting 2 to 6 would be failure. So you could have multiple numbers, but you have to be able to define an event as success and the rest of them a failure, okay? And then the number of trial is fixed. So you're not just like trying to find out, oh, I want to see how many times I need to roll a die until I get 1. That's more geometric, right? Binomial is that I'm going to roll it 10 times and see how many 1s I get. Okay, so you're counting how many things that you're getting and a fixed number n. So this is where n comes from. Independent, meaning that your probability stays the same each trial, right? And independent also means that your first so like your outcome does not affect the next outcome. So the 10% condition, guys, 10% condition, the first appeared for this chapter. So it was your sample size had to be less than 10% of your population, or you are doing something with the replacement, right? So without replacement, then it wasn't independent. All right, geometric, again, it's exactly two outcomes, success and failure, right? And then trials are independent. And then the probability of success is same each trial. So what is the difference between geometric and binomial? Well, geometric is basically you're saying, I want to see how many times I need to do this until I get my success. So you're looking for first success, right? So you don't have a fixed number, okay? So n unknown, right? You're just doing it until you find the first success, okay? Normal distribution. So binomial distribution sometimes can use normal approximation, and then the conditions that you have to meet was this: NP and NQ, right? Because Q is 1 minus P, had to be greater than or equal to 10. And then the large enough condition, which is the 10% condition, has to be met to assume the independence, right? So this one was done to assume independence, because unless it's something that you can clearly say is independent event, you have to show the condition being met to assume independence, okay? Then you could use a binomial, normal approximation for binomial distribution. And binomial distribution was used, the notation was this: B and P. And the normal was this, right? Mean and the standard deviation. All right, these are the steps for simulation. My time is running out, and I'm just going to have you read it because it's not very hard to understand, but it is very important that you follow these steps to describe how your simulation is conducted, okay? And I'm going to go through this a little more in the next video, and then I'm going to share this so that you can have this formula and then other things that you can write for your own notes, okay?